Hi guys, today we'll talk about properties of logarithms. So the first one we have here, we have log base b of y times x or x times y. What does that mean? Well, we're going to apply the product property of this log expression right here. So what that means is the log of a product is the same as the sum of the logs of the numbers. So the base doesn't change. The base is always going to be the base. So log base b of x plus log base b of y. So in this, you can go from here to here and then from here to here. So depending on what your question is, you can apply from here to here and that will make your life easier. Or you can know that when you have these numbers right there, you can go from here to here. We will have examples later. So now the multiplication inside the logarithm changes to addition on the outside. Now the next one, we have the quotient property of logarithm. So quotient is when you have a number divided by another number, or in this case, we're just using letters to represent any numbers. So the log of a quotient is the same as the difference of the logs of the numbers. So that looks like this. So log base b, again, the base doesn't change, log base b of x minus log base b of y. And again, just like the product, you can go from here to here and then from here to here. So the division inside a logarithm changes to subtraction on the outside. This is what it looks like in words. This is what it looks like in math language. Now, this is the power property. So the log of a number raised to a power is the same as the power times the log of a number. What does that look like? So you're going to get the power and put that right there in the front, multiplying. So it's the power times the log of the number. So p goes in the front, and then you multiply log base b of the argument x. Voila. So the secret here, this power goes in the front multiplying. Okay? So the power inside of a logarithm changes to multiplication on the outside. Now, the two next properties, they're like the same as the power property, but it's just kind of a shortcut. So notice that the base and the arguments are the same. So when the base and the arguments are the same, then your answer will be just the exponent, in this case, p. So we're using p to represent that. Here's an example. So log base 2 of 2 to the 6th power equals what? When the base is the same as the argument, then your answer is just the exponent. So x equals 6. So if the log base and the argument are the same, it is always equal to the power. Don't know. So now here you don't have the exponent, right? But you kind of do. So the exponent here, it's an invisible 1. Invisible 1 right there. So it's the same as this property and the same as that property right there. It's just some things that I wanted you to know, and it's obvious, so we don't have to think too hard when you're doing this. So base is the same as the argument. Therefore, your answer is the exponent. In this case, 1. Base, the same as the argument. In this case, 1. Okay, that's what it says right there. Okay, change of base property. The newer calculators will allow you to use a different base than just base 10. The older calculators don't. Sometimes you're not going to be allowed to use a calculator in your test. Don't know. That's when you need to know the change of base property. So the way this works, you're going to have log, the question, is log base b of n. So you're going to do log of n over log of b. So notice that the base is going to go in the denominator, and then the argument is going to go on top. This is going to be like just base 10 on both. We already covered when we don't have anything, the base, the default base is 10. Let's practice. So here for us to calculate log base 4 of 32, we will use the change of base property. So log of 32 over log of the base, in this case, 4. Now you can calculate that. Now we will get to the point where we're solving functions, we're solving equations using the log properties. So we're going to work the same way. Think about x plus 1 being the argument. So log of the argument, x plus 1, over log of the base, in this case, 2. Goodbye.